Hello everyone, myself I am RUPESH JAISWAL. I am here to explain you color television experiment. This experiment is being explained to you virtually because this COVID-19 and the lockdown declared by our government of India. Okay, so you should not miss any knowledge regarding how to do or how to carry out the experiment of this color television kit. So let us start this explanation without wasting time. Just try to recall in last lecture or previous lecture I have explained you the block diagram of black and white television. Though today we will see how to carry out the experiment related to your color television, but before that you have to understand and you have to recall how exactly black and white television works. Okay, so I will just scroll a few slides uh, and immediately you will understand that from where we have to start this and where we have to end. So initially I will explain you how this black and white television works. Thereafter I will explain you the block diagram of color television, which I have already explained to you, but now for taking practicals and taking readings, this block diagram you need to recall. Then we will go the actual trainer kit which is available in our laboratory. So this is basically a trainer kit, and when you switch on you will see the different waveforms or different picture output on this screen that I will explain you. Thereafter I will explain you the details how to do the DC analysis part and how to do the AC analysis part. Okay, so this is what the agenda of today's explanation, that I will start with the black and white television block diagram. Then I will explain you the color television block diagram, then the actual color television trainer kit, and as usual there are two parts to conduct or carry out that experiment. One is DC analysis and another is AC analysis. So now we will start the explanation with the black and white television receiver. Okay, so just see the basic blocks. The input of this black and white television receiver is nothing but a tuner. Thereafter you have a common IF amplifier and video detector stage. Always keep in your mind that after this common IF amplifier and video detector, three different signals are taken out. The first signal of 5.5 MHz intercarrier frequency goes to the sound demodulation section. So this is known as sound demodulation section or frequency FM demodulation section. So the output of this common amplifier, this common IF amplifier and video detector, as I told you, there are three outputs. Number one goes to FM demodulator section. Number two, after video amplification, it goes to the cathode of this black and white television. And third, from this video amplifier the signal goes to this sync separator, where H sync and V sync signals are separated. H sync signal drives H oscillator, V sync signal drives V oscillator. Likewise, V oscillator output 50 Hz and H oscillator output is 15625 Hz. Ramp signals are available. So if you see these two signals, the nature of that waveform is ramp in nature. So 50 Hz ramp output given to the vertical coil and 15625 Hz ramp output from the horizontal section is given to the H coil. So H coil, as I told you, is responsible to move the beam generated from this cathode from left to right, and this vertical coil is responsible to move the beam from top to bottom. Thus left to right and top to bottom the raster is generated, and whatever video signal which is applied at the input of cathode will be converted into picture information. One more signal from this horizontal output amplifier goes to this EHT, where the extra high tension transformer is there, and as I told you, 1 kilovolt per inch, this is what the EHT voltage which is required as a final accelerating anode voltage, which is positive in nature, a DC voltage in nature, that is constant DC voltage you need to apply at the final accelerating anode of this cathode ray tube, CRT tube. So 1 volt per inch. So if your television is 14 inch, approximately 14 kilovolt is generated. If it is 17 inch, approximately 17 kilovolt is applied at the input of this final accelerating anode. And if you go for 25 inch and above, then normally 33,000 volt and so on voltage is required as a EHT voltage. Now this I have already explained you in my lecture how this black and white television works. Thereafter we will move to color television. So this is the simplest block diagram of any color television. So color television may be a PAL color television, E&TC color television and SICAM color television. Since we are using PAL standards in India, so we will see the PAL color television. So if you compare this color television block diagram with respect to the black and white television, then very simple, let us say I will explain you the similarities first. The signal is coming from Yagi-Uda antenna, and that signal is given to the tuner input. Okay, very first block. If you compare the black and white television also, so see this is the black and white television. From Yagi-Uda antenna, the signal goes to the tuner first, then common AF amplifier and video detector, and from that 3 signals are taken. One goes to sound section, another goes to video amplifier section, and third goes to sync separator, that is H sync, V sync, H oscillator, V oscillator, H coil, V coil. The same circuitry is normally used in color television also. See the similar block diagram. The first tuner, then common AF amplifier and detector. From that 3 different signals are taken out. One goes to the sound section. This is basically a FM demodulator section, and output of this FM demodulator you get audio output. If it is a mono, it is a mono loudspeaker. If it is a stereo, then normally 2 loudspeakers are there. Then second signal goes to the video amplifier and a chroma section. So compared to black and white television block diagram, if you see, a chroma section is added instead of video amplifier directly. And third output from this video common AF amplifier and video detector, the third output goes to the sync separator, where H sync and V sync signals are separated, and the output of H oscillator is 15625 Hz and output of vertical oscillator is 50 Hz. Thus H oscillator, that is 15625 Hz, or this voltage which is given to this H coil, is responsible to move the beam from left to right, and this vertical oscillator output which is connected to this vertical coil, which is responsible to move the beam from top to bottom. So try to understand one thing, that the initial stages are almost same if you compare black and white and color television. And this color television same, the 3 outputs are there. One goes to FM demodulation section, another goes to chroma section, and third goes to sync separator and H coil, V coil and EHT section. So from this H coil itself, H oscillator itself, this signal is taken, given to the EHT rectifier. So if it is 25-inch television or more than that, then 33,000 volt DC is required as a final accelerating anode and given as a EHT constant DC supply to this color picture tube. So what's the main difference? If you see the black and white television block diagram, see this chroma section, instead of only video amplifier, the chroma section is there, and instead of black and white picture tube, you will find a color picture tube is there. So this is the chroma section, and this is what the color picture tube. So the chroma section, when this chroma section of this PAL television receiver is nothing but PAL decoder, where the signals are taken, they are processed, and finally red, green and blue, these voltages are generated and given to the red, green and blue cathodes of this television picture tube, and this video signal is converted into picture information back. So one more thing is there, a SMPS power supply is required, and the SMPS power supply which is used in this color television trainer kit, 230 volt input is given here, and output which are available is 115 volt DC, 33 volt DC, 12 volt DC, 115 volt, 33 volt and 12 volt DC. Okay, now I have recorded this and I have explained you the black and white television receiver. Now we have recorded color television receiver, a generalized block diagram also. Now directly we will go to the color television trainer kit which is available in our lab, and then we will see how to carry out this experiment. Now we will see, this is the color television trainer kit which is available in our laboratory. So trainer kit is nothing but the implementation of the block diagram. Block diagram, theoretically the working of that block diagram, color television receiver kit, I have already explained you. Now practically such type of kit is available. So what is this trainer kit? If you go to market, you will find a color television receiver, not the kit. The kit manufacturers are different. So what is the difference between this kit and a color television receiver which you purchase from market? The difference is very simple. The color television, the processing circuitry is there on printed circuit board. Instead of manufacturing or implementing the entire color television receiver on a single kit, what this manufacturer of this trainer kit do, they take the separate section of this television, and it should be easier for explaining to the students. That's why these trainer kits are designed accordingly. So now try to understand and try to correlate the process of signal flow. So if you see this color television block diagram, very simple, a tuner, video AVE amplifier and a detector section, or common AVE amplifier and detector section, from which three outputs are taken. One goes to FM demodulation, another goes to chroma section, and third goes to sync separator section. The same thing I will explain you in this color television kit. So just try to recall a very first stage. Okay, a very first stage in your color television is tuner. So this is indicated over here. So from Yagi-Uda antenna the signal comes to tuner. Then you will find the discrete stage as a common AVE amplifier and video detector. So this stage indicates the common AVE amplifier and video detector, and from this three different signals are taken out. One goes to a sound section, another goes to a chroma section, and third goes to a sync separator, that is H oscillator and V oscillator section. So please keep this in your mind. Once again I am telling you. So if you see this, a Yagi-Uda antenna, a tuner section, common AVE amplifier and video detector, from these three different signals are taken. One goes to FM demodulation, another goes to chroma section, and third goes to sync separator section. The same thing is explained over here. This is the first section, that is a tuner section, and from this tuner section the channel is selected, given to the common AVE amplifier and video detector section, which is indicated by this sky blue color. Output of this goes to three different sections. One goes to sound section, so this is the sound section where the FM demodulation takes place and given to the loudspeaker. Then from the same section one signal goes to this chroma section. This chroma section is going to process the video information. Finally, this red, green, blue, if you see this red, green, blue, the signals are available. They are amplified and given to the cathode of this picture tube. Okay, the wires are taken from this red, green, blue, and given to the cathodes of this color television picture tube. Then one more signal is taken from this common AVE amplifier and video detector. It goes to H sync separator, V sync separator. H sync drives H oscillator section, V sync drives V oscillator. H oscillator output is available over here, vertical oscillator output is available over here. So vertical oscillator output is directly connected to the vertical coil of this color television. H oscillator output is amplified. Actually, more voltage is required compared to vertical. So this H oscillator output is given to the H output, and finally this 15625 Hertz output signal ramp is amplified and given to the H coil. So thus H coil is responsible to move the beam from left to right, and vertical oscillator output, which is amplified and given to the vertical coil, is responsible to move the beam from top to bottom. So now you have understood, okay, the different section, and we have compared this with this color television. Okay, now other than that, few more sections are there that we will see. Okay, now we will see the different other sections of this color television. So now this is tuner, common AVE amplifier and video detector. One signal goes to sound section, so this is sound processing section. The output is nothing but loudspeaker. Then another signal goes to this chroma section, where this R minus Y, B minus Y, G minus Y signals are processed, and finally you will get red, green, blue output and given to this color television picture tube. And one more output from this common AVE and video amplifier stage goes to H sync separator, V sync separator, H oscillator, V oscillator, then H coil and V coil of this color television. From H oscillator output itself, just try to recall this section. From H oscillator output, E&TC rectifier is there, and it is connected to extra high tension, that is 33,000 volt is connected to the final accelerating anode voltage. The same thing is done over here. So if you see this black section is nothing but extra high tension transformer. So whatever H oscillator output is given to this extra high tension transformer, number of primary turns are less and number of secondary turns are more. That's why the boosted voltage and this boosted voltage output is given by V output is equal to L into di by dt, where di by dt is nothing but rate of change of current through these secondary turns, and L is the value of this secondary turns, and hence V output L into di by dt is huge. That's why this extra high tension of 33,000 volt is generated with this E&TC, and it is applied to the final accelerating anode, which is the requirement of this CRT based picture tube. Okay, so now other than this main section, few more sections are there. Now just see this pink section, that is infrared receiver. So whatever signal which is coming from the remote transmitter or color television remote, okay, the infrared signals are transmitted, and this infrared receiver is there in your television, which take the signal, and this infrared processor gives the commands to different stages or section of this color television trainer kit. So what are those commands? The commands are channel plus, channel minus, sound plus, volume minus, then tuning of the different channels, brightness control, contrast control, color control, and so on. So all those signals, they are received with the help of this infrared receiver section, and accordingly those commands are given to different section to control the different remote control operations. Okay, now here all of you see SMPS section. Okay, it was already indicated in color television block diagram. Okay, So if you see this color television block diagram, this SMPS is required, and the output of SMPS is 115 volt, 33 volt and 12 volt. So if you see this, okay, the output of this SMPS, see this. Now one more thing I would like to tell you, that wherever this there are two types of bulbs which are indicated: a yellow bulbs which is flashing, and another is this white bulb which is flashing. So I will tell you how to take readings and all these things, but now you keep this in your mind that this is what the SMPS section. When the 230 volt is given to this switched mode power supply, there are basically two types of power supply: linear and SMPS. Linear power supply is not used because it becomes bulkier here. So so the effective output, the television become bulkier. To avoid that, this SMPS switch mode power supply is used in this color television trainer kit, and the output, wherever this white bulb is glowing over here, okay, here there are basically three outputs, that is 115 volt, 33 volt and 12 volt. 115 volt DC goes to the this horizontal output stage to a amplifier section, okay, which drives this EHT. Then 33 volt, 0 to 33 volt DC is given to this tuner to select the different channels, that is VHF low, VHF high and UHF band channels are selected with the help of this 0 to 33 volt. And one more voltage, that is 12 volt, is taken out, sometimes 18 volts, okay, 12 volt to 18 volt DC voltages, they are generated from this SMPS, and they are given to the different section like H oscillator, V oscillator, sound section and so on. So there normally this DC voltage is required. Now all of you give attention. Now we have correlated the actual color television block diagram and this color television processing kit. So what is important thing is, now as we have carried out the different experiments in our audio video engineering lab, there are two things, means taking reading. They are divided into two parts. Number one, DC analysis, and another is AC analysis. So DC analysis, when the kit is in working condition, the DC voltages are measured with the help of multimeter, and when you are talking about AC analysis, the different waveforms, they are observed on DSO. So normally we take the DC voltages on multimeter and we take the AC readings on the digital storage oscilloscope which is available in our laboratory. So now if you keenly see, there are animated images which I have purposefully put up in this explanation. So wherever yellow light flashes, there we have to take the AC analysis, we have to take the readings, and wherever this white bulb, okay, flashes, there we have to take the DC analysis. So now all of you give attention. So whenever you give 230 volt and switch on this trainer kit, then the initial DC analysis, see this white bulb is flashing. So here basically three outputs are available. One is 115 volt, second is 33 volt and third is 12 volt. So with the help of that you can directly measure. So the DC analysis you can complete. Then number two is AC analysis. In AC analysis, what you are expected to observe, see this, come to this chroma section. Here you will find colorplex composite video signal. So composite video signal, initially you have to note down. So this yellow bulb is flashing. So here colorplex composite video signal can be observed. Number two, H oscillator, 15625 Hz ramp output will be observed at the output of this H oscillator. So this yellow color indicates 15625 Hz ramp. Now V oscillator, this flashing yellow bulb, here you have to take the reading of V oscillator, and the frequency you are aware of, that is 50 Hertz. So fourth is sound section. So in sound section, this yellow color indicates that here you have to take the AC analysis reading. So you have to take the reading from this sound section. So what are those readings? Output of this sound section, audio left and audio right. So frequencies you are aware of, that I have already explained to you, and we have seen it in detail. If it is a men's pitch, then 110 to 8 kilohertz. If it is a woman's pitch, then it is 220 to 10 kilohertz, right? And if the song is being played at a back end, if you consider a scene with a song, then definitely you are aware of that, the fundamentals and their harmonics. So the frequency which you need to write is 20 Hertz to 20 kilohertz. So only men's pitch 110 to 8 kilohertz, women's pitch 220 to 10 kilohertz, and if it is a song with different musical instruments, then you have to consider the frequency as 20 Hertz to 20 kilohertz. So now you must have understood. Now black and white television block diagram I explained you, color television block diagram I explained you, and this is the color television trainer kit. So you have to take the readings wherever the different bulbs are flashing. So in DC analysis, what I told you, in SMPS output 115 volt, then 33 volt and 12 volt supply you have to measure, and one more white bulb is flashing over here. So red, green and blue, when the color television is working properly, then red, green and blue, this amplifier DC voltages, they are around 60 volts. So this is about the DC analysis, this reading which you have to take carefully on the multimeter. And the second part is AC analysis. Number one, from this chroma section you can take the reading, that is colorplex composite video signal. Okay, then number two, H oscillator 15625 Hertz ramp output, then V oscillator 50 Hertz ramp output, and finally 4 sound output, sound left and sound right. So if it is a men's pitch, it is 110 to 8 kilohertz. If it is a woman's pitch, then it is 220 to 10 kilohertz. And if the song is being played with the different musical instruments, then at a back end you have to consider all those frequency, and which reaches to 20 hertz to 20 kilohertz. Now we will see so the DC analysis, white bulb, as I told you. Number two, AC analysis. Just try to recall, you have drawn these waveforms multiple times in different experiments. So this is the colorplex composite video signal. So you are aware of, this is one line video signal. Then you have horizontal blanking pulse of 12 microsecond, on the top of which you have H-sync pulse, because of which there are two parts, front porch of 4.7 microsecond, back porch of 5.8 microsecond, and this horizontal sync pulse is of 4.7 microsecond. And one line video signal, the time period is 52 microsecond. So 52 microsecond of video and 12 microsecond of horizontal blanking pulse, if you add it, you will see a 64 microsecond. So 1 upon 64 microsecond is nothing but 15625 Hertz. So colorplex composite video signal, so many times I have already explained you in our laboratory. Now H oscillator, H oscillator output is 15625 Hertz. See, this is V oscillator and this is H oscillator. So H oscillator output is 15625 Hertz, where the ramp is moving from this 0 to up. So it is this period is of 52 microsecond, and retrace period is of 12 microsecond. So 52 plus 12, 64 microsecond. So 1 upon 64 microsecond is nothing but 15625 Hertz. And as far as these vertical details are concerned, the frequency is 50 Hertz. And if you divide this 1 upon 50 Hertz, then this is the trace period of vertical waveform, that is 18.72 millisecond, and vertical retrace waveform is of 1.28 millisecond. So 18.72 millisecond plus 1.28 millisecond, if you add, so it becomes 20 millisecond. So 1 upon 20 millisecond is nothing but 50 Hertz. So this is vertical frequency, and this is horizontal frequency, and this is colorplex composite video signal. So these three parts are over as far as AC analysis is concerned, and this is audio left and audio right. So you are aware of how this audio frequency on DSO or looks. So it looks like this. So whether it is audio left or audio right. So only rule which you have to remember, and accordingly you have to write this on your graphs when you draw this waveform on the graph. So you have to keep this in mind that if the main speech is there, what is the frequency you are going to write? 110 to 8 kilohertz. If it is a woman's speech, then it is 220 to 10 kilohertz. And if the musical instruments are being played at a back end, the song is going on, then what will be the frequency? 20 hertz to 20 kilohertz. So this you have to write, or you need to write whenever you draw this waveform on your graph. Okay, so this is what complete explanation of color television experiment, okay, which is there in our laboratory, in our audio video engineering experiment list. This color television experiment was not completed. It was about to complete, but because of this COVID-19 and lockdown, we could not conduct it in our laboratory. But now this is the complete explanation how to conduct this experiment or carry out the experiment, and how to do the DC analysis and AC analysis in our laboratory, audio video engineering laboratory. So if you have any question, you please ask me. If there is no question, then we'll move ahead, and we will conclude this session. Thank you very much. Thank you for listening with patience.